Okay, pre-calculus students, this is an additional video to help you with 6.3b. I'm going to be giving you 6.3b notes in this video. If you look on page 424 and read the formulas for unit vectors, you're going to see something that looks like this. The unit vector is the vector divided by its magnitude. So in the case of number 59, you're given that the magnitude is 8. And the vector that you want to go in the same direction is 5, 6. So the way this is going to work is first I find out what this unit vector is of u. And then I'm going to multiply it times 8 because then that will make its magnitude 8. And that's what it's asking us to do, to find a vector that has this magnitude and goes in the same direction as this. So first job is to get the magnitude of u, which is the square root of 5 squared plus 6 squared. That's the square root of 25 plus 36, which is the square root of 61. And now I'm going to take that vector and divide it by the square root of 61. And that's going to get me 5 root 61 over 61, comma 6 root 61 over 61. Now, my last stop is to multiply the whole thing times the magnitude of 8. So that's going to get me 8 times 5 root 61 over 61, 6 root 61 over 61, which will finally get me the square root of 40 root 61 over 61, comma 48 root 61 over 61. And I checked it in the book, and that is the correct answer. Next, number 69. Says you have this vector u, which is defined in I and j form as 2i minus j. You could write it in component form as 2 comma negative 1. And another one called w, which is I plus 2j, which in component form is 1, 2. So they ask you to find this new vector, which is u plus 2 w's. So I personally would rather work with the I and j form than the component form, and then change it to component form at the end. So u plus 2w is going to be 2i minus j, that's u, plus 2 times I plus 2j. And oh, we're asked to graph this too, so I'm going to want to see what those look like anyway. And now I can just combine these as though they were variables. I'm going to get 4i plus 3j, and that's my vector v. And so what does that look like in terms of a graph? Well, I know I'm not going to need more than 5 in any given direction, so I'm going to make my grid accordingly. I'll call that 2, 4. Call that 4 in each direction. And I'm going to graph first my resultant vector, which is 4i plus 3j. So I'm going to go 4 in the horizontal and 3 in the vertical. And that is my vector v. Now, you can arrive there by taking u and adding 2 w's. So u is 2i minus j. So this is u. And then 2i plus 4j from there. So I go 2 to the right and 4 up. 1, 2, 3, 4. And we'll hold it's right there. I'm going to get something that looks like that. So that's u. This is 2w. And that's how we graph that. The reality is I don't need all this extra piece here. If I'm trying to conserve space on my paper, I can make this look prettier. Just like that. Okay. Next is 75. On 75, they ask you to, well, first we need to know that if I have a vector u written in component form as x, y, I can write that as the magnitude of u times the cosine of theta sine theta. And theta is the angle that we turn to get to that vector from the x-axis, rotating in a positive direction. So in 75's case, they tell you that v is a vector defined in I and j form as 12i plus 15j. So what I need is I need to know what the angle is, and I need to know what the magnitude is. Magnitude's easy, it's the Pythagorean theorem, so it's the square root of 12 squared plus 15 squared, which is the square root of 144 plus 225, which is the square root of 369. And I notice that both 36 and 9 are divisible by 9, which is going to leave me with 41. So I get that square root of 9. So that's actually going to be 3 root 41. Okay, so there's my magnitude. Now to get theta, I have to remember that theta, the tangent of theta is equal to y over x. And y in this case is 15 and x is 12. So that means that the inverse tangent of 15 over 12 is going to get me theta. So that's what I'm putting in my calculator right now. The inverse tangent of 15 divided by 12 is about 51 degrees, 51.34 degrees. And so now I know what theta is because my calculator, after I did the inverse tangent, tells me it's 51.34 degrees. Now I want to make sure that that makes sense. So I'm making a little sketch of this. A little sketch of it tells me I go 12 this way and 15 this way. It's going to look like that. It's going to be in first quadrant. So that's a first quadrant answer. That's a reasonable angle for that. It's a little more than 45. So that sounds like the right answer. So my magnitude is 3 root 41 and my theta is 51.34. And then that brings us to number 89, which says the same kind of thing. It says that we have a magnitude. This time we're going the other way. They're giving us the magnitude and the angle. Magnitude and the angle. And saying we're going to add these together and tell me what you get. So we already know if we use this formula, we're going to find out the component form. So we're going to do that on both of these, and then we're going to add those components together, and it'll tell us the new vector. So the whole thing is going to look like this: 20 cosine 45, comma, sine 45 degrees, plus 50 cosine 160, comma, sine 160. Oops, got to get my funky looking greater than parenthesis. Okay, so now this I know, but this I'm going to need the calculator for. So this is going to be 20 times root 2 over 2, root 2 over 2. This, on the other hand, is 50 times the cosine of 160, making sure I'm in degrees, it is, which is negative 0.9397. And then the sine of 160, which is 0.3420. So now I just multiply that times 20, multiply that times 50, and then add the two parts together. So I'm going to get 10 root 2, 10 root 2, because the 20 and the 2's will cancel for both of those. And then 50 times that is about negative 46.98 and 17.10. So now I just add those together. So I'm just going to take this and add 10 root 2 to it, which gives me about negative 32.84. And if I add 10 root 2 to 17.10, I get about 31.24. And I just checked it in the book. That's the correct answer. So that's how you do the more complicated problems. And not really that difficult. Just got to follow the instructions. There are more examples in the book, but if you get stuck, send me an email. And I'll probably send you to another video. Good luck.